it with 4.5. Okay, 4.5. So this one is called as the Poisson approximation of binomial probabilities. Okay. So when we have the binomial distribution, okay, so binomial distribution in your stats table, you just have your n up to 30. So again, what happens when your n is greater than 30? Okay, n equals to 32, you can still use your stats table. Okay, but for certain name, you can also use the approximation when your n is equals to 30. It depends lah. Okay. Dua alternatif. Kalau n tu sama dengan 30, boleh guna sama ada nak guna approximation pun boleh. Still nak guna table pun boleh sebab n equals to 32 still provided in your stats table. Okay. So again, when n is greater than 30, okay, your n pi is less than 5. Okay, biasanya pi kamu tu yang kecil lah n pi tu less than 5. So when you have this case, your x, which is your binomial, it becomes to a Poisson distribution. Kita approximatekan binomial distribution tu, you have n and also pi to the Poisson distribution. So Poisson, you will have lambda equals to n pi. Okay. Kali ini kita punya min kan? Mu untuk binomial adalah n pi. Okay, dalam kamu punya parameter lambda maksud kamu adalah min number. So in this case, your lambda is equals to n times pi. Okay. So for example, this one, task 4.21. Okay, x is binomial. N equals to 500, your pi is 0.003. Okay, let's say we compute n pi. Okay, so you have 500 times 0.003. Okay, so you have 1.5, which is less than 5. Okay, if you want to use your stats table, you don't have n equals to 500. Okay, so that's why we need to change to Poisson distribution with min 1.5. Then you can solve. Then we solve lah. Probability x equals to 4. Okay, we use lambda equals to 1.5. Okay, lambda, x equals to 4. Okay, this one, it will be probability x less than equals to 4 minus x less than equals to 3. So we will have 0.9814 minus 0.9344. Okay, and then you get what is the probability. Okay, so you have 0.047. Okay. The next one, you want to find probability x greater than or equals to 5. So the same thing. So you will have 1 minus probability x less than or equals to 4. So still use lambda 1.5, your Poisson. Okay, so 1 minus 0.9814 lah. Okay. Okay. Probability x less than 3, so does not include 3. So probability x less than or equals to 2. So again, use lambda 1.5. Your k now is equals to 2. So should be 0.8088. Okay. That is how we get the value for lambda, which is your lambda is just n times pi. Okay. Case when you have your n is greater than 30. If you want to approximate to Poisson distribution, when you have n greater than 30, your n pi is less than 5. So that's mean you need to check. Okay, sebab kita ada binomial ni, it can approximate to Poisson or it can also approximate to normal distribution. Okay, where we have normal approximation, that one. Okay, so now we look at the question. Okay, task 4.22. Okay, ini kamu tukar dulu ya, sekejap. Okay. Okay, you change this one. You just add 0.5%. Okay, saya kira dulu. Okay, you change ya. So ini this one you use 0.5% instead of 5%. Okay, 0.5%. So we want to find what is the probability that more than 4 flights are not on time. Okay, airway flight from Kuala Lumpur to JB is not on time, 0.5% of the time. So we have 130 flights were observed. Okay, if we read the question should be on binomial distribution. Okay, binomial distribution. So again, your X is binomial, your N is 130, so 0.5%. So 0.5% macam mana nak tulis? So you will have 0.005 Okay, times with 130. Okay. Okay. So again, this one, what is the probability that more than 4 flights are not on time? Okay, you find your lambda. Okay, your lambda, Y katakan itulah X, Poisson, 0.65. Okay. So now you want to find more than 4. Okay, since lambda 0.65 tu tak ada. Okay, tapi biasanya kalau dalam test tu kita bagi yang ada yang ada dalam stats table. Okay, lambda 0.65 tu tak ada. So let's say lah we took 0.7. Okay, we ambil yang paling dekat dengan dia which is your X. Sebab kita tak ajar interpolation Poisson 0.7. Okay, so we use 0.7. So what is the probability that more than 4 flights are not on time? So that's mean you want to find probability X greater than 4. So X greater than 4. So again, 1 minus probability X less than equals to 4. Okay, cuba compute. What is your answer? Okay. Dapat apa jawapan dia? Okay, 0.0008. Okay, sure dah. Thank you. Okay. So again, you will have, I use lambda 0.7 1 minus probability X less than or equals to 4. Okay. So again, you will have 1 minus 0.992. Okay, so 0.0008. Okay. Okay, the next one, what is the probability between 8 and 15 flight are not on time? So between you don't have any equality. So 8 less than X less than 15. Okay, still use lambda 0.7. Okay, so that's mean we will have, okay, you want 9, 10, 11, 12, 13, 14. So probability X less than equals to 14 minus apa ni? Probability X less than equals to 8 So then you get 9, 10, 11. Okay. So lambda 0.7. Probability X less than equals to 14 should be apa? 1 Okay. Minus probability X less than equals to X. Also 1. Okay. So then you get 0 lah. Dalam case ni. Okay. Because the value kini dalam table kamu K equals to 6 tu dah 6 K equals to 6 tu dah 1. Okay. So that's mean in this case you have this one lah. 1 minus 1 which is 0 probability. Okay, any question for this one? Sebelum kita sambung. Maksudnya bila you read the question is originally coming from binomial. Okay. But again, binomial, your n is greater than 30. Okay. You check n greater than 30 and then you check your pi. If you get n pi less than 5, you continue on with a Poisson distribution ataupun Poisson approximation. So guna lambda. So lambda equals to n pi. Okay, that's mean all the question you will solve using the Poisson distribution. Okay, remember because binomial ni kita ada dua. Kita akan check n pi tu. Kalau n pi dia less than 5, Poisson. N pi greater than 5, normal. Okay. Okay, task 4.23. Okay, sekejap ya, betul tak ni? Okay. Okay, cuba try. Ini boleh kot, 0.1%. Okay, there is a 0.1% chance that the shipment of transistors from a supplier is defective. A factory will only accept the shipment if there are not more than 20 defective transistors in a shipment of 2,000 transistors. What is the probability that the factory will accept the shipment? Okay, baca dulu dia punya soalan dia. Okay. So again, you have a probability 0.1%. Shipment of transistor from a supplier is defective. Okay. Factory will only accept the shipment if they are not more than 20 defective transistor in a shipment of 2,000 transistor. Okay, N dia apa kat sini? Is it N dia 20 or N is 2,000? What is your N? Number of your trial ataupun number of your sample size. Okay, anyone? What is your N? Okay, N is your 2,000 Okay, 2,000, good. Okay, now you write in terms of binomial distribution. So that's mean you will have your X, okay, binomial distributed as 2,000. Pi is 0.1%. So 0.1%, 0.001. Okay. So now a factory will only accept the shipment if they are not more than 20. Lepas tu dia tanya, what is the probability that the factory will accept the shipment? Okay. So now you change dulu. Lambda. Dapatkan lambda equals to n pi. So 2,000 times 0.01. Okay, lambda is equals to 2. Okay, so you will have X Poisson lambda 2. Okay. The probability? A factory will only accept the shipment if they are not more than 20. Not more than 20 tu kita nak tulis macam mana? Tidak lebih daripada 20. So maksud dia apa? Tidak lebih daripada 20. Tidak lebih, tidak kurang. So you will write less than or equals to 20. Okay, not more than 20. So again, X less than or equals to 20. Tidak lebih daripada 20. Not more than maksudnya less than or equals to 20. Okay, probability X. Okay, lambda equals to 2. Jawapan dia apa? Kalau dapat table. Lambda equals to 2, your K is 20. Ada tak K equals to 20? Okay, kalau tak ada, that means your answer should be 1. Okay, sebab dia semakin ke bawah tu, semua total probability dia 1. Okay, good. Yeah. Okay. Okay, the last one. Okay, the last one. Sama tukar. Kalau tidak, dia tak dapat ni. Okay, kamu tukar this one. Again, 0.1%. Okay, cuba dulu buat. Okay, so task 4.24. So again, this one, factory access produce components which 0.1% are defective. Okay, components are packed in 800. So again, this one is binomial distribution. So you will write your X is binomial distributed 800. So this one should be 0.001. Okay. So again, your N is greater than 30, your N pi is less than 5. Okay. So we change to Poisson distribution. So X Poisson 0.8. Okay. So you want to find the probability that the box contain at least 12. So at least 12 defective. So again, if you have lambda 0.8, okay, at least 12. So dapat apa tu? What is your answer for this one? 1 ke 0? Last answer, last answer. You get either 1 or you get either 0. Probability X greater. Okay, 0, yeah. Okay, so that's mean 1 minus 1 lah. Okay. Okay. Second one, find the probability that there are 3 to 9 defective components in the box. Okay, so that's mean probability 3 less or equals to X less than equals to 9. Okay, this one. So that's mean 3, 4, 5, 6, 7, 8 up to 9. So probability X less than equals to 9. Okay, minus X less than or equals to 2. Then you get 3, 4, 5, 6, 7, 8, 9. Okay, this one you have again lambda 0.8. So ini 1 minus 2, 0.9526. Okay, so you will get 0.0474. Okay. Okay, do you have any question up to here? Ada apa-apa soalan tak? Okay. Sekejap ya. Okay, kita dah habis dah ni. Chapter 4. Okay, laju sangat ke saya aja? Ke you all boleh follow ke setakat ni? So far? Is it okay for everyone? Okay. Yang ni dah belajar ke? I mean the Poisson approximation. Did you learn in your, saya pun tak ingat, during your SPM belajar tak? That's mean binomial tukar pada Poisson. Is it in the syllabus for SPM? Or not included? Tak ada kan Poisson you all tak belajar kan waktu SPM? Okay. Okay, I stop sharing this one first. Okay, you try do this one. Okay. Macam tadi juga. Okay, cuba bacakan dia punya soalan dia. Identify what is your lambda and then what do you want to find lah in this case. Okay, cuba dulu. Okay, so we refer to this exercise. So again, astronomers treat the number of stars in a given volume of space as a Poisson random variable. Okay. The density in the Milky Way galaxy is in the vicinity of our solar system is 1 star per 16 cubic light years. Okay. So in this case, what is your lambda? Which one is your lambda? Is it lambda is equals to 1 or lambda is equals to 16? Huh? Is it? Okay, lazy say lambda is equals to 1. Okay, okay, okay. So again, in this case, if you read the question carefully, okay. So given is 1 star per 16 cubic light years. So 16 cubic light years tu macam kamu punya volume lah. Okay, volume of your space tadi. Okay. So lambda in this case is 1. So that's mean if you want to define your random variable, okay, your x is, you take this one, number of stars in a, okay, number of stars, okay. Number of stars, okay, in 16 cubic light years lah. Okay, so x distributed as Poisson, lambda 1. Okay. So the question asks you what is the probability of 2 or more stars in 16 cubic light years. So then nak cari probability x greater than or equals to 2 okay, 2 or more. So x greater than or equals to 2. Okay. So again, this one is 1 minus probability x less than or equals to 1. Okay, because you want 2, 3 up to infinite. So 1 minus probability x less than equals to 1. Okay, now we use lambda equals to 1. Okay, lambda equals to 1. So 1 minus, apa siapa kamu? 1 minus 0.735873, mana tinggal? Okay, 7358. So you have 0.2642. Okay, that is the first one. Okay. So part B. So part B is the same thing macam kita punya exercise tadi. So how many cubic light years of space, okay, must be studied so that the probability of one or more stars exceed 0.95. Okay. Kita tulis dulu dia punya bentuk salinan one or more star. Okay, maksudnya x greater than or equals to 1 exceed 0.95. So this is the way how you need to write. Okay. Probability x greater than or equals to 1, okay, exceed 0.95. So 0.95 ni is your probability. Okay. Probability x greater or equals to 1. So that means you will write 1 minus probability x equals to 0 greater than 0.95. Okay, you want to solve. Okay, you need to solve this one. Okay. Okay, you will have 1 minus probability x equals to 0 greater than 0.95. So again, you will have 0.05 greater than probability x equals to 0. Ataupun probability x equals to 0 less than lah. Okay. So now, saya tulis balik je ni. X greater than less than 0.05. Okay. Probability x equals to 0. So that's mean you will have exponential negative lambda. Okay, that's mean you need to find what is your lambda first. Okay. Lambda to the power 0 divided by 0 factorial less than 0.05. So since we have exponential, so take ln on both sides. Okay, log E, so ln. So minus lambda ln E. So lambda to the power 0 is 1. 0 factorial is also 1. So less than ln 0.05. Okay, and then you solve. Okay, dapatkan ln E ln 0.05. Okay. So you have this one. Right. Dapatkan 2.99 tu. Okay, cancel out negative. So you will get lambda greater than 2.99. Okay. So that's mean we will take lambda, approximately lambda equals to 3. So the question asks you not to find lambda, but how many cubic light years of space must be studied. Okay, so berapa jawapan dia? What is your answer? Dapat apa? Okay, so that means 63 times 16. Okay, first you need to find what is your lambda, and then find, darabkan dengan dia punya tu dah, kita 60 cubic light years, so that's mean 48 cubic light years. Okay, so that's mean first, you use your lambda, okay, to find the probability. Okay, macam biasalah yang hafal tu. And then second, you will have given the probability, and then you need to solve for lambda first, and then try to answer that question lah, apa yang ditanya. Kalau yang tadi tu ditanya, dapatkan M je, dapatkan dia punya nilai lambda, and then guna that lambda tu to solve the other question. Okay, but this one, dia tanya balik apa dia punya ruang tu. Okay, which is this one lah, in this case, 16 cubic light years tadi.